Greetings, folks. This video is going to be devoted to trying to let you see what an inductor does in an AC circuit as far as its frequency response goes. Very quickly, I'm going to show you what the circuit looks like. So I have my function generator here. I'm going to take from the high, well, actually there isn't a high voltage side, but I'm going to take from one of the leads. It's going to go here. This is a coil here, so that it's going to go through the coil to this connector. I'm going from here to here like so. And then I'm going to go through a resistor, which essentially is a light bulb, and it's going to come back to the power supply. I want to go ahead and see what's going on with the power supply as far as its voltage output goes. So channel A on my oscilloscope is going to be devoted to what's happening with the power supply, and there I've got that set up. And then channel B, I'm going to put it across the resistor so I can see what's going on with the current flow in the circuit. Okay. So channel A, you can see it's right here. Channel B is down here, so I'm going to bring this up. I want the voltage to be 1 volt peak to peak. 1 volt amplitude, which is 2 volts peak to peak. This thing is on a 0.5 volt per centimeter. So each one of these little hash marks is worth 1/10 of a volt. So I basically got 20 of them. That means I'm going to have 2 volts peak to peak, which is the same as 1 volt amplitude. So what we're going to do is we're just going to pan through the frequencies. We're going to start I've got 40 cycles per second on here. You can see at 40 cycles per second with 2 volts peak to peak, you have a pretty good size output. It looks like it's measuring around, 1.2 to 1.3 volts. That's not enormous, but it's not tiny either. Watch to see what happens when I bring the frequency up. So I'm going to bring the frequency up to 100 cycles per second. So I'm at 105, bring it down. Actually, might as well get it dead on. No reason not to. Oops. So I'm now at 100 cycles per second. Let me take a look at this here. And it looks like we're looking at about, 1.2 volts, give or take. I'm going to bring this up to 200. And you will notice that the voltage has dropped down some. Now it's at about, 0.95, give or take. So it seems to be diminishing. I'm going to go up to 300 cycles per second. And you need to realize that if all I had across here was a resistor, the input and the output voltage would be the same. There would be no variation with frequency. Whatever the voltage was across the resistor would always be the same no matter what frequency you were pushing through. In this case, I'm pushing through 300 cycles per second, and the output is now even smaller than it was before. It's now at like around, 0.75, give or take. I push it up to 500 cycles per second. It's looking to be about, about 0.35. If I shove it all the way up to 1,000, you can see that it's almost gone away completely. And certainly if I push it up to 2,000, okay, the inductor is essentially not allowing any of the signal to pass through at all. So apparently at low frequency, the inductor is perfectly willing to allow current to pass through the circuit. As the frequency gets higher and higher and higher, it's less willing, which means its resistive nature must be such that at higher frequencies, there's more resistance to charge flow. And when we talk about the theory, it will become evident why that's the case. I had intended to actually have you take data, but because this function generator isn't working quite the way I was hoping it would, I'm basically going to tell you what I did, the data that I took, which is basically right here. And I'm actually even going to make life even easier for you. I graphed the data, and this is what the graph ended up looking like. So you are going to be asked to make sense out of it. This up along this axis is the voltage peak to peak. This is the frequency going from low frequency to high frequency. At high frequency, there wasn't very much voltage output. So as I said, you're going to be asked to go ahead and make commentary about this in the lab write-up that you're going to do, but you're not going to have to actually do the graph. You will have to do a graph similar to this for an RC circuit, and you will get the data from that in the next video.